In this question, we have to calculate the relation between the current I and I dash. If we see almost both of the networks are same, this resistance is also 2 ohm. So this is 2, 2, 6 ohm, 6 ohm, and 2 ohm. This is also 2 ohm. Here it is voltage source and resistance, here it is current source and resistance. So we can convert this also. If we convert current source into voltage source and resistance, then we have this 6 ohm and 18 volt. Now we have to calculate the relation between I and I dash. We need not to calculate anything. Both of the networks are same with one simple modification. That is, every source has been multiplied by 1.5. Here 12 volt, 12 multiplied by 1.5, that is 18. 12 multiplied by 1.5, that is 18, and 8 multiplied by 1.5, that is 12. So all the sources have been multiplied by 1.5 and resistances are same. Then the current will also be multiplied by 1.5 by the homogeneity rule. So I dash will be equal to 1.5 I. So relation between I dash and I is given by option C. Our answer for this question is option.
Polar plot of a system is given. It is shown that the intercept made by the polar plot on minus 180 axis is minus 0.5. It is also shown that the phase of the system at the point at which the polar plot intersects unit circle is 40 degree. Question is to find gain margin and phase margin of the system. Gain margin is reciprocal of the gain of the system at phase crossover frequency. In other words, it is a reciprocal of the intercept made by the polar plot on minus 180 axis. Phase margin is 180 degree plus phase angle of the system at gain crossover frequency. The point at which polar plot intersects unit circle, at that point, length of this phasor is 1. This is gain crossover frequency. Their phase is given to be 45 degree. Phase angle measured in clockwise direction is negative. Hence, the phase margin of this system is 140 degree. Answer to this question is D.
In the next question, we have to check for out of these four options for which signal Fourier series representation cannot be defined. As we know, Fourier series representation is possible only for periodic signal. So if any of this signal is non-periodic, then Fourier series representation will not be possible. Option D is the DC signal, and DC signals are periodic signal. So for option D, Fourier series representation is possible. Option C is again periodic. Here these two terms are periodic and the resultant term will be periodic if a ratio of their frequencies will be a rational number. So in option C, if we will check ratio of frequencies, then it will be equal to this. This ratio will be equal to 2, and 2 is a rational number. And if this ratio is rational number, then summation of 2 or more than 2 periodic signals will be periodic. Therefore, option C is also periodic. Option B is a sinusoidal periodical signal. So option B is also periodic. But in case of option A, if we will check the ratio of frequencies omega 1 and omega 2, then a ratio will be like this: 200 pi upon 100 t. Pardon me, here some correction is needed. Here the term is cos 100 pi t. Now if we will check option A and we will check the ratio, then ratio will be like this, 200 pi upon 100. So it will be equal to 2 pi, and 2 pi is an irrational number. And if ratio of frequencies is irrational, then summation of periodic signals will be non-periodic. It means option A is a non-periodic signal, and for any non-periodic signal, Fourier series expansion is not possible. So for option A, for this question answer is option. In the next question, we have to check whether the given signal is energy, power, neither energy nor power, or which type of signal. Now, first of all, we will calculate energy of signal x of n. Energy in case of discrete is given by formula summation mod xn square over the range minus infinite to plus infinite. We can write down this signal in this form also. For n equals to 0, if we will put n equals to 0, then first term will be 1. Now, for the remaining range, we can write down in this way, summation minus infinite to minus 1 mod xn square plus summation 1 to infinite mod xn square Signal xn is an example of even signal, and if this signal is even, then these two summations will be same. So these two terms are same. So we can write down in this way also, 1 plus 2 in bracket 1 plus 2 into summation 1 to infinite mod xn square. So we can write down in this way also, summation 1 to infinite. Now modulus of xn is a की power n, and its square value will be like this. So we can write down in this way, 1 plus 2 into summation 1 to infinite a की power 2n, or a square raised to n. Now it is an example of infinite extension GP. So we can write down result in this way also, 1 plus 2 into a result of infinite extension GP is first term upon 1 minus ratio, but magnitude of ratio should be less than 1. Here ratio is a square, as magnitude of a is less than 1, therefore magnitude of a square will be also less than 1. So this condition is satisfied here. It means summation will be finite, and if we are going to calculate summation, then first term will be a square. When we will put n equals to 1, then we will get the first term, and first term is a square. Divide by 1 minus ratio. A square is ratio of this GP. So the result will be like this. Since a is a finite value, so this summation is also finite. And we already know, if energy of signal is finite, then type of signal will be energy type. Therefore signal xn is an example of energy signal. Now when we will look at all four options, then option B will satisfy this result.
Given potential V is 5 rho square sin 2 pi volts. Find Laplacian. Laplacian means del square V. Find Laplacian of V, that is del square V, at point rho is equal to 2, pi is equal to pi by 3, and z is equal to 1. So that is the question. Now given coordinate system is cylindrical system. In cylindrical system, del square V Laplacian formula 1 by rho, dou by dou rho, rho into dou V by dou rho plus
1 by rho square dou square V by dou pi square plus dou square V by dou Z square. So this is the formula, and this is 1 by rho dou by dou rho into partial differentiation of this one with respect to rho, that is 5 into sin 2 pi is constant and you get 2 rho plus 1 by rho square with respect to partial differentiation with respect to pi. In this case 5 rho square is constant, and one time you differentiate, then d by dp of sin 2 pi is cos 2 pi differentiation, so you get 2. Once again if you differentiate this, then you get minus sin 2 pi into 2, so you get 2 square. Partial differentiation of v with respect to z 2 times, it is not a function of z, so the answer is 0, this one. Now once again if you differentiate this with respect to rho, here 1 by rho 5 into 2, that is 10, sin 2 pi come out, here rho square is there, so you get 2 rho. Then here 1 by rho square, that is cancel, and sin 2 pi into 2 square. If you see here, this cancel, and this is nothing but 5 into 4, 20, that is here also 20 is there, so 20 sin 2 pi minus 20 sin 2 pi. So your answer is 0. So option is
A PROM, it is having 8 inputs pins and 4 output pins. And from the given following statements ABCDs, we need to recognize which is the right answer to the given statement. Whenever the PROM, programmable read-only memory, is having 8 input pins, then first block what we are looking as a decoder will be with 2 to the power of 8 outputs. So because of 8 inputs, the decoder will be with 2 to the power of 8 outputs. So that basically we are having decoder of size 8:256. So each output is basically a minterm on these 8 inputs, and we are having the PROM with 4 outputs, so that we are in need of number of OR gates 4, and each OR gate with 256 inputs. So the fan in for each OR gate will be 256. So based on this, the matching answer is option D.
This question is about a PNP transistor circuit in which we are asked to calculate what are the terminal voltages, emitter voltage, base voltage and collector voltage. Now by observation, base voltage will be equal to 3 volt. So there is no calculation for that. We can tell directly base voltage equal to 3 volt. And then we can obtain emitter voltage in this way. VB is equal to base voltage minus emitter voltage. If I rearrange, emitter voltage will be VB minus VBE. That base voltage is 3 volt and VB for PNP transistor will be minus 0.7. So minus into minus becomes plus 0.7 and that will be 3.7 volt. And then you can calculate emitter current, which is the current passing through this 1.1k resistor. It will be 9 minus emitter voltage divided by 1.1k. It will be 9 minus 3.7 divided by 1.1. And if we calculate this I, it will be 4.818 milliampere. Now from emitter current we can calculate collector current. It is alpha into emitter current. That alpha will be beta divided by 1 plus beta. 30 divided by 31 into 4.818. And if you find it out, it will be equal to 4.62 milliampere. Then you can tell collector voltage. Collector voltage will be the drop across 0.56 kilo ohm. Collector voltage is equal to 0.56 into IC. And if you find it out, it evaluates to 2.61 volt. So in this question, emitter voltage is 3.7 volt, base voltage is 3 volt, and collector voltage is 2.61 volt. Now if you look at the options, answer has to be the option.
So in this problem, induction motor runs at speed of 710 rpm with an input power, it is given 35 kilowatt. We need to calculate the gross torque developed. Okay, so first of all here, ns, the synchronous speed is 120 f by p, that is 8, and it is 750 rpm. Omega s from here is 78.54 radian per second. So just we have converted it in omega s. Now the slip, it is the rotor speed, it is given is 710 rpm. So from here the slip is equal to 0.053. So omega r or rotor speed in radian per second is 74.38 radian per second. Now once we have calculated these all speed and with slip, then the electrical power input, it is given as 35 kilowatt and stator copper losses are given. So air gap power or input power to rotor is basically the stator input, that is 35 kilowatt minus stator losses, that is 1.2 kilowatt, and the value is 33.8 kilowatt. Now the gross torque T gross is 33.8 into 10 to the power 3 divided by 78.54, and this is equal to 430.354 Newton meter. So our answer is
Accumulator after execution of the given program. So move immediate A comma 65, accumulator contains 65H. Move immediate B comma 88, B contains 88H. Add the content of B to A, that is 88 added to A, 8 plus 5 is 13, 13 is written as D, 6 plus 4 is 14, 14 is written as E. And after that, DAA stands for decimal adjust accumulator. Accumulator value is adjusted to the decimal value. So the difference between decimal number system and hexadecimal is 6, therefore 16 minus 10 is 6, and hence there are two conditions for DAA. While adding, if the auxiliary carry is 1, then the lower nibble is added with the 6, or if the lower nibble is greater than 9 or higher nibble is greater than 9, then also 6 is added. Therefore, if you compare this lower nibble, E means 1110, 1101, it is greater than 9, and hence 6 is added to this. This 1 plus 1 0 1 0 1. This 1 is also considered. Is the higher nibble greater than 9? Yes. Therefore, here also 6 is added, and hence 1, it is 0 1 1 1 0 1. Carry flag is 1. So the content of accumulator after the execution of the program is 53H. The option.
In a manufacturer, company consists of two independent parts of A and B. In the process of manufacture of part A, 9 out of 10 are likely to be defective. So probability of defective products in A is 9 out of 10, 9 out of 100. Now, so non-defective is 1 minus 9 by 100. that is 91 by 100. Similarly, in the case of part B, 5 out of 100 are likely to be defective. So probability of B defective is 5 out of 100. So non-defective is 1 minus 5 by 100, that is 95 by 100. Now, what is the probability that assembled article will be defective? So first you calculate assembled article will be non-defective. Non-defective is A dash into B dash. So 91 by 100 into 95 by 100. If you simplify this, you will get 0.8645. This is for non-defective. Therefore, probability that the product is defective, 1 minus 0.8645, it is nothing but 0.1355. In this problem, we have to find out directional derivative of 1 by r in the direction of r bar. In the direction of r bar. Now, we have to find directional derivative of 1 by r. So, phi is 1 by r. We have to find directional derivative is nothing but grade phi dot a bar by mod a bar. A bar is nothing but r bar by mod r bar. Now, first we have to find grade phi. This is our function. Now, del phi is I bar del phi by del x plus j bar del phi by del y plus k bar del phi by del z. Now we are going to differentiate this with respect to x, next y, next z. Now, I bar. Differentiation of 1 by r. 1 by r is nothing but 1 by x square plus y square plus z square whole power 1 by 2. Differentiation of this function with respect to x. 1 by 2 minus 1 by 2 into 1 by x square plus y square plus z square whole power 3 by 2 into 2x plus j bar of minus 1 by 2 into 1 by x square plus y square plus z square whole power 3 by 2 into 2y plus k bar minus 1 by 2 2z by x square plus y square plus z square whole power 3 by 2. If you simplify this, you will get here 2 to cancel, 2 to cancel, 2 to cancel. So minus r bar by r square whole power 3 by 2 minus r bar by r cube. Now minus r bar by r cube into r bar by mod r bar is nothing but r, that is dot product between r bar and r bar, you will get x square plus y square plus z square by r power 4. This is nothing but r square. So minus r square by r power 4, that is minus 1 by r square.
In this question, we have been given two identical two-port networks with h parameters this, and they are connected in series at input port and parallel at the output. Then value of the alpha such that the combined network will be symmetrical. Now, if combined network is symmetrical, then delta H for the network should be equal to 1. The condition for symmetricity. Now according to the question, at the input port they are connected in series and at the output port in parallel. So H parameter should be added to get the combined H parameter. So combined H can be obtained by H1 plus H2, and both are same, so it can be written as twice H1, and this is equal to 2 into 0.3, that is 0.6, plus 2 into 1.2, that is 2.4, so 2 alpha, and this is 5. This is the value of H, and for condition of symmetricity delta H is 5 into 0.6 minus 2 alpha into 2.4 should be equal to 1. So 2 alpha into 2.4 is equal to 3 minus 1, that is 2. So alpha is equal to 1 upon 2.4. The value of alpha is 1 upon 2.4, and this 1 upon 2.4 will be equal to 0.417. So answer for this question is 0.4.
Block diagram representation of a system is given. Question is to find the value of the sensitivity of the transfer function of the system with respect to alpha parameter for the values of S and alpha given. First of all, finding the closed loop transfer function of the system with the formula G by 1 plus GH, it becomes alpha by S square plus S plus 2 alpha. This is the closed loop transfer function. Question is to find the sensitivity of this closed loop transfer function, which denoted by T with respect to alpha. Formula alpha by T delta T by delta alpha, which when calculated, this closed loop transfer function has to be differentiated partially with respect to alpha parameter, then multiplied with alpha by T. The result comes out to be S plus 1 upon S square plus S plus 2 alpha. We are asked to find this value for the value of S is equal to minus 2 and alpha is equal to 2. Substituting these two values in this function, the result becomes 0.33, and the answer to the question is 0.
In this question, we need to calculate KD and the 36 slot 4 pole 3 phase winding is given. So we know that KD is equal to sine m beta by 2 upon m sine beta by 2. So from here, m is slots per pole per phase, that is 36 divided by 4 into 3, it is 3. Then the beta, the slot angle, is basically 180 degree divided by slot per pole. So this value is equal to 20 degree. Once we have calculated m and beta, just putting those all values in the equation number 1, the KD is approximately equal to 0.96. So our answer is 0.96.
This question is about calculating the output voltage in the op-amp circuit. Now in this op-amp, there is negative feedback present because of 200 kilo ohm and 100 kilo ohm connected towards inverting terminal. Negative feedback will occur, and with negative feedback present, op-amp will be considered to be in linear region, and when op-amp is in linear region, the two input terminals are virtually shorted. We may say that node A and B are virtually shorted. So we will get the output voltage by using that virtual short property, VA equal to VB. And before that, let me obtain VB with the help of KCL at that node B. If I use KCL at node B, we get 4 minus VB divided by 20 plus that minus 4 minus VB divided by 10 is equal to 0. If you simplify this, it will become 4 minus VB minus 8 minus 2 VB is equal to 0. Or if you rearrange it, it will be like 3 VB equal to minus 4, or VB equal to minus 4 divided by 3 volt. And then you can apply virtual short property, VA equal to VB. VA equal to VB. That VA you can write through voltage divider. It will be V naught into 100 by 100 plus 200. V naught into 100 divided by 100 plus 200 is equal to minus 4 divided by 3. And this will become V naught divided by 3 is equal to minus 4 by 3, or V naught equal to minus 4 volt. So in this question, output voltage is minus 4.
We are having here a question for the given function f, which is x or z and with w bar or y. To implement this, the question we are looking as how many minimum number of 2 input NOR gates required. The given expression we are having in the product of some form. When the expression is in the product of some form, we are having possibility to implement this by using 2-level NOR circuit, so that we want to read here the function f, so that here we want to have a sum term x or z, here we want a sum term w bar or y. So for this NOR gate, x and z must be inputs, and for this NOR gate, w bar and y must be input. To get w bar, based on the given statement, in the given statement it is mentioned only uncomplementary form of the variables are available. To get w bar, we need one NOR gate, so that if you count the total number of gates, we are looking the total number of gates are 4. Hence answer is 4.
Now in this case he is asking us to calculate the error in the reading of the voltmeter. In digital voltmeters, the error specification is given in two parts. The first part is the error due to the reading, which is the systematic error, which is occurring because of the A to D converter component of the DVM, and the second component is given as plus or minus x digits, which is the counter's error. So in this case he has given the error specification as plus or minus 5% of the reading and plus or minus 1 count or plus or minus 1 digit. We will solve this numerical in two components. The first component is A, error due to reading. The error due to reading, he says, is going to be 5%. 5% of what? 5% 5 volts. So therefore 5% of 5 volts will be, this is going to be 5% of 5 volts is going to be 0. Plus or minus 0.025 volts. This is the first component of the error that we are talking of. The second component of error that we will be talking of in this case is the error which is going to be because of the count. Now, B, error due to counts. The reading of the voltmeter will always be in terms of the voltage per count into the total number of counts. So in order to calculate the error due to one count in this case, what we need to do is we need to calculate the voltage per count for the 10 volt range. So the voltage per count for the 10 volt range can be calculated by the total number of counts in a 3.5 digit DVM is going to be 1999, and the voltage per count is going to be 10 volts divided by 1999 counts. So therefore I will write here voltage per count for the 10 volt range, because he has given the full scale voltage as 10 volts. This is going to be 10 divided by what is the number of counts in a 3.5 digit DVM? The total number of counts in a 3.5 digit DVM is going to be 1999. Whether you take it as 1999 or count 0 also, it could be 2000 counts. Whether you take 1999 or 2000 is not going to make a major issue. So the error in this case is going to be equal to 10 divided by 1999 is going to be equal to, the value will be equal to 0.005 volts, plus or minus of 0.005 volts. The error has been specified as plus or minus 1 count. So I will say, therefore, error due to 1 count will be voltage per count into number of counts. In this case, I am taking the number of counts for the error specification. So this is going to be 0.005 into 1. This is going to be plus or minus of 0.005 volts. The total error in the reading of the voltmeter is going to be the sum of the error due to reading and the error due to the count. So total error in this case is going to be sum of the error due to the reading, that is 0.025 plus 0.005, which is the error due to the count. This is going to be how much? This is going to be 0.03 volts plus or minus. Now, this is the absolute value of the error in the measurement of voltage in a voltmeter whose error has been specified in these terms. So calculating the percentage error, one thing we need to remember here is that while calculating the percentage error in the digital instrument, we always calculate for the given reading. The given reading of the voltmeter in this case is 5 volts. So therefore, error while reading 5 volts will be, or rather the percentage error is going to be equal to the total error, that is 0.03 divided by 5 into 100. This is going to be plus or minus 0.6%.
We have to find out the solution of the system 5007 inverse x minus y equal to minus 1 2. Then x plus y is, so first you have to find x value and y value. This is in the form of a inverse of x minus y equal to minus 1 2. Now x minus y equal to 5007 into minus 1 2. Now x minus y is minus 5 plus 0, 0 plus 14. Now x is minus 5, y is minus 14. Now x plus y is minus 5 minus 14, that is minus 19. In this problem, the velocity of a particle from the rest is given in different time instants. Now we have to find, by using Simpson's 1/3 rule, we have to find out the distance traveled by the particle in 20 minutes time interval. In 20 minutes. So here we have to find out by applying Simpson's 1/3 rule, integral 0 to 20 v dt distance. Now by Simpson's 1/3 rule, h by 3 of y naught plus yn plus 4 into odd y1, y3, y5 and so on, plus 2 into even y2, y4, y6 and so on. Now this is y0, y1, y2, y3, y4, y5, y6, y7, y8, y9, y10. Now h is width 2 units, so 2 by 3 of y0 is 0, y10 is 0,
plus 4 into y1 10, y3 25, y5 32, y7 11, y9 2 plus 2 into even y2 18, y4 29, y6 20, y8 5, y10 we already considered in the place of yn. Now simplifying this we will get 309.33 meters. That is the total distance traveled.
The unit impulse response of an initially relaxed two-port network is this. Ht is given as e to the power minus 2t plus e to the power minus 3t ut. If the zero state response of the network is b naught t is t e to the power minus 2t ut, then the corresponding excitation of the network we have to calculate VIT. HT, so corresponding HS is 1 upon S plus 2 plus 1 upon S plus 3, that is S plus 3 plus S plus 2 upon S plus 2 into S plus 3. It is 2S plus 5 divided by S plus 2, S plus 3. V naught T, so corresponding V naught S is equal to 1 upon S plus 2 square. Now, we have V naught S upon VIS, that is equal to HS. So, V naught S is given to us and we have to calculate VIS. So, VIS is equal to V naught S divided by HS. That is VIS is equal to V naught S 1 upon S plus 2 ka square into HS 1 upon HS. This is S plus 2, S plus 3 upon 2S plus 5. So S plus 2 cancel. So it will come out as S plus 3 upon S plus 2, this one, and 2S plus 5, this one. If we make partial fraction of this, then we will be having 1 upon 2 outside, and this is 2 upon S plus 2 minus 1 upon S plus 2.5. We take Laplace, inverse Laplace transform of this expression, then VIT is equal to 2 will cancel out, e to the power minus 2t minus 1 upon 2, and this is e to the power minus 2.5t. This one ut, that is the answer. So, which is given in option D. So, our answer for this question is given by option